Welcome back, everyone, and this is another little code quick demo. Like in the first one, I did like a figure eight type of curve, and thanks for someone on Twitter, Alexander, because I said the next one I want to work with is with Watt's curve, but I can't find any examples of how it's implemented. So I think he gave me a page that has I can't remember what it was. I think he already gave me the equation of okay, so he found this page where it has the polar parameterized equation for creating that curve. And this curve is really kind of cool because you can change the parameters and you can end up creating a bunch of different weird shapes just by doing different things. You can create a figure eight, you can do a circle figure eight. I don't know, you can disc weird shape, but you just have to get these values to hit just right. You have this weird path. So like that's I'm really kind of curious about this one, and I couldn't find the equation, and he found this, and like I said, it's only important in polar coordinates, and it's timed. As long as it's timed, I can then convert it into convert it into Cartesian coordinates. So this is the equation for the radius, and this is the equation for the angle. Or this is the length and this is the angle. So once you have the angle and the length, it's very easy to calculate the x and y position. So I was able to implement that equation into code, and like I said, it's t as a parameter, and then you have these other values, which a stands for the distance between the center of two circles, b is the radius of circles, and c is the length of the rod. The rod is basically the thing that connects the two circles together, and it's the center point of that rod that actually does the actual drawing. I wanted to emulate that rod, but I was having a hard time actually figuring out how to visualize it. So the best I can do is visualize the circles or where they are and how big it is, but I can't really visualize the actual rods that are moving. I'm just having a hard time because the visualization of the rods is that one rod moves and the other one has to follow along, and I kind of need like a physics engine type of thing to have one rod force the other rod to move, and that's how because this equation, the Watt's curve, is designed to kind of help calculate things related to trains, the train wheels. So you have the train, you have one wheel that spins, and you have the other one that has a rod that connects to the other wheel, and it forces the other wheel to rotate along with it. So you only have one set of wheels that's moving, and the other set of wheels is moving. It's being forced to move, and that's what the Watt's curve does. But when you use the center point of that rod, you can use it to draw patterns, and you have to get really cool patterns. You kind of have to get these numbers just right. Like I said, if you research Watt's curve, you get to see different patterns or like different numbers of how to create interesting patterns. Like I know if I make the circle distance and the rod distance equal, I can then make a perfect figure eight, no matter what size. Or no, the size will change. Circle size. So you can like this is a great equation to create like a custom version of a figure eight. So you can really customize a figure eight. That's kind of why, because the last video I was doing a figure eight. If I as long as I make these match up, I get a perfect figure eight. So yeah, you can play around with the numbers. The source code is now available. I'll put the link out to GitHub, and you can go out and play with it. Because like I said, there's not really anything online that you can actually just play around with the Watt's curve. And like I said, it's a really cool algorithm you can use to kind of use as paths, because it's time it's parameterized with time. So this way you can, like I said, you can make a circle move around it. The only thing that's missing that at some point I might do would be to calculate its derivative. So this way I know the direction that I'm currently going at. But I really didn't feel like spending time The first derivative was a pain in the ass for me to figure out to do. I just didn't feel like doing the other derivative. But if anyone wants to calculate the derivative of Watt's curve, please send it to me, and I'll implement it as code, and I will play around with it. I'll just add on to this example, and maybe I'll make another quick mini and show off, and you guys will get the credit for writing the derivative of the Watt's curve. And like I said, you can probably just go to this site, and there's the equation. So it's just the derivative of p and the derivative of sine. I'm pretty sure derivative of p should be easy. It's negative b cosine t. Yes, I think that's probably the derivative of p. So I probably could create the derivative if I really wanted to. I'm just being lazy. Like this, I just didn't feel like dealing with it. But yeah, just create two derivatives, and that should do the job. And if you want to take the source code and see if you can draw the lines that point the direction of where the derivative is supposed to go, as a way to test it to see if your derivatives are correct. That'll be all. I guess I'll see you guys in the next video.